we have an object that's going to be launched at various heights. So here's the initial height, if that's a platform, and then I launch something off of it, it goes up, it comes down, it hits the ground. And this is the equation representing this object being launched. The initial height will happen to be the c value in the quadratic. So that is at a height of 3. And then it goes up and it comes down. So we want to know, when will the ball be 8 feet off the ground? Now, if you know that it starts off at a height of 3, it goes up, so higher, higher, higher. Eventually it'll be to a height of 8. If the very highest point is an 8, then let's say the height here is 8. It goes up even higher, comes back down, it's at a height of 8 again, and then eventually hits the ground. So we should have 2 answers. Now, if this platform would have been at 15, then I'm only gonna have a height of 8 one time. Because if it started off at a height of 15, it would already be above a height of 8. So a height of 15, go up, 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 down, 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 and eventually be to a height of 8. So it could have 1 answer, and then, or 2 answers, depending. Okay, we'll look at it algebraically, like how do you know if you forget that that is the initial height of the object, but you can reason it out that way. Okay, so I'm gonna put in, this guy right here is representing the height of the object. So here's the height of the object, but I want the height to be, instead of h, I want that to be 8. If you're gonna solve a quadratic equation, step 1 is move everything to the same side equal to 0. And we have several options when we're solving quadratics. One of them would be to factor, set each piece equal to 0. But I'll tell you ahead of time, these particular ones are not gonna factor. And you're gonna settle for an estimate. We're gonna put it in our calculator. So we just wanna move everything to the same side equal to 0. I'll go ahead and add 5t squared to the other side, subtract 13t, and then when I subtract 3 to the other side, 8 minus 3 is 5, and now this equals 0. It's in the form ax squared plus bx plus c, so I can use the quadratic formula. Okay, so one more time. Adding 5t squared moves it to the left, subtracting 13t moves it to the left, and subtracting 3 to both sides is moving everything to the left. Okay, so my a is 5, my b is negative 13, and my c is 5. We're going to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So my a is 5, b is negative 13, and c is 5. So negative b is negative 13, b squared, negative 13 squared, minus 4 times a, which is 5, c, which is 5, all over 2a, so 2 times 5. And from here, we're going to settle for an estimate. I usually, depending on how nice of calculator I have in my hand, I usually just go ahead and find the answer to the discriminant first. So I'm going to take negative 13 squared minus 4 times 5, let my calculator do that, and that's going to end up being, in this one, 69. Negative 13 is going to be 13, and 2 times 5 is 10. So we end up with 2 separate equations to solve. We have 13 plus the square root of 69 over 10, and 13 minus the square root of 69 over 10. So 2 separate ones that we want to enter. When you're using your calculator, if there's a lot going on in either the numerator or the denominator, you want to put an extra set of parentheses around the numerator or the denominator. The only thing in the denominator here is 10, so I don't need an extra set of parentheses around the 10, but I am going to put an extra set of parentheses around the numerator so I can type it straight into my calculator. So I've got, notice I put a set of parentheses divided by 10. If this would have been, if I would have left it 2 times 5, then I would want to put those in parentheses. Okay, so I'm going to type inside of here 13 plus the square root of 69. So 13 plus the square root, when you use a square root symbol on your calculator, it pops up a parenthesis. So then 69, finish the parenthesis of the square root, and then the blue ones are just putting the top in parentheses. So you hit enter. If you don't want to do that, then you're going to want to take 13 plus the square root of 69, enter, get an answer, and then divide by 10. Okay, and then I do the same thing here except for with a minus. So just putting in that guy. And this is the time, so at 0.47 seconds, and I've rounded to the 100th, at 0.47 seconds, the height of the object is 8, and again at 2.13 seconds, the height of the object is 8. So it started off at a height of 3, because that's the C in this. It went up, time is going by, so at 0.47 seconds, it's at a height of 8. More time goes by, and at 2.13 seconds, we're at a height of 8, and then eventually it hits the ground. Okay, a couple follow-up just items so that we don't have to do a million examples. If it says, when does the ball hit the ground? Instead of, when is the ball 8 feet? Well, if you want to know when the ball hits the ground, think about what's the height of the ball when it's on the ground. 0, right? So then that would tell me to replace the 8 with, instead of having an 8, I'd have a 0 for the height of the ball. And then if you end up solving these and one of your times is negative, you can't have a negative time. So you're like, well, why is that happening? That's just because you have a situation where the object was launched at a height higher than the height you wanted. So like the one I started off with, I'm like, what if that was a height of 15? And I said, when is it going to be a height of 8? Well, if I'm at a height of 15, I go up, I'm not going to be at a height of 8 until I'm right there. So it's only going to happen once. But this has symmetry, so if you follow this backwards, it'd be at a height of 8 way back here. But time didn't start until this, so you got a negative time. And so that's why you'd throw that one out. So don't panic if one of your answers ends up being negative. It just means you're going to throw it out.